Hello and welcome. In this presentation I will take you through how to calculate the length of a line segment. Now, just as a recap, we will be using Pythagoras in this session to calculate the length of the hypotenuse. Now, if I had a right angle triangle with one side length being 5, the other side length being 6, and I'll just identify this side as being h for hypotenuse, then I could say that h squared equals one side squared plus the other side squared. So h squared will be equal to 25 plus 36, and if you follow the maths through, we can see that h equals 7.81. Now, we'll be doing a very similar thing to find the length of a line segment, or the distance between 2 points. Now, this is the approach that I like to follow. Now, say I have a coordinate here of -3, 3, and another one at 5, 6, and I wish to find the length of a line or the length of the line segment between those 2 points. This is the approach that I will follow. I will construct a right angle triangle. So I'll go up and across, and there you have it. There is my right angle triangle. I could, if I wanted to, go this way. Doesn't matter. Then I will identify the lengths of the horizontal and the vertical legs. So here is my vertical leg. How far is that? How many units? 1, 2, 3. So I will look at the horizontal leg. How many units? 1, 2, 3, 4, 5, 6, 7, 8. So 8. Then I know my right angle is here. This is my hypotenuse. So I will calculate the length of the hypotenuse using Pythagoras. So ls squared, this length here, I've just called ls for line segment, equals 3 squared plus 8 squared. If you follow the maths all the way through, the length of my line segment will be 9.5. Now let's move to another example. One dot over here, one point, the following point here. Alright, construct a right angle triangle. Well, this time I'm going down and across, and there you have it. There's my right angle triangle. Identify the lengths of the horizontal and vertical legs. So vertical leg is 5, horizontal leg, well, is 12. Then calculate the length of the hypotenuse. This one here is the hypotenuse. Hypotenuse because it is across from my right angle. So I can say that this line segment squared is 5 squared plus 12 squared. If you follow the maths all the way through, the length of the line segment is 13. Now, there is a generic formula that you can use. If I consider the x coordinates between here and here, the distance between those x coordinates is effectively one coordinate minus the other. If I look from the vertical perspective, the distance will be one y coordinate minus the other. Then it's effectively this squared plus this squared will equal the length of the hypotenuse squared. So that is the generic formula. So let's just move on to our final example. Say I wanted to find the length of the line segment between the one set of coordinates that is at 1, 2 and the other set of coordinates that is at 5, -8. I can just basically nominate one set as being x1, y1, the other one being x2, y2. It does not matter which way round you have that. Then I can populate the formula. So 5 minus 1 all squared, and -8 minus 2 all squared. Ends up being 16 plus 100. There's your 116. So the length between those 2 points on the Cartesian plane will be 10.8 units. So there you have it. I hope this presentation has assisted you in determining the lengths of line segments, and until next time, good maths. Bye for now.